Hello everyone, today we're gonna do a calculation. This calculation is often used with titrations. We have an acid, we have a base, and we're gonna get a product out of it. So we have OH minus and H plus, and we're gonna have water out of it, H2O, and this is actually how it works. So what do we know? The solution is 7.97 milliliters of OH minus. That's what we have. That's the known number we have, and the equation is OH minus plus H plus is H2O. So everyone reacts 1 on 1. That's what we know. So the amounts of moles on OH minus is the same as the amount of moles of H2O. And then we know that the molarity, the mole per liter of OH minus is 0.1. That's moles per liters, or also millimoles per milliliters. That's the same. And what do we want to know? We want to know the amount of grams of H2O. That's what we want to have in the end of this video. So let's start with really calculating. So what we need to know now is how to calculate the moles and the molarity. And we can calculate the amount of moles if we have grams divided by the molar mass. And if we have moles divided by the volume, we can get the molarity. However, we have the molarity and we have the volume. That means if we have the molarity times the volume, we can get the amount of moles. And if we can get the amount of moles, we can use the molar mass to get the amount of grams. So first, we had 7.97 milliliters, so we make it liters. So it's 7.97 liters times 10 to the power of minus 3 times 0.1 molar is 7.97 times 10 to the power of minus 4 moles. And we know that OH minus and H2O, they have the same amounts of moles. They react 1 on 1. So we can consider that H2O, no, we don't consider, we don't even assume. We know that H2O has 7.97 times 10 to the power of minus 4 moles. However, we need to have the molar mass of H2O to get the amount of the amount of grams H2O. So let's do that. So we have the amount of moles of H2O. That means we can calculate the amount of grams. The molar mass times the amount of moles is 2 grams, and the molar mass of H2O is really easy to find. If you have a periodic table, you just count 2H and 1O and you get like 18.02. I took the easy way. I found the molar mass of water on Wikipedia, but if you're having a test, that won't be that easy. If you are in the Netherlands, you have at least a BINAS. I don't know how it works in other countries, but if you have a sheet with molar masses, you will be okay. So the molar mass of water is 18.02 grams per mole. And we know that we have 7.97 times 10 to the power of minus 4 moles. So we do that times each other and we get 1.43 times 10 to the power of minus 3 grams of H2O. So the most important thing about this topic, about working with molarities, is knowing which ratios are right and knowing the formulas. If you know the formulas, you can do it easily. There are other formulas you can use, and with bigger titrations it's going to be more and more difficult. And for this is actually just high school stuff. If you don't know it anymore, you can watch this video again. But working with molarity is really easy. It's not a lot of maths, it's just knowing what to do on the right moment, on the right time. I hope you enjoyed this episode. It's about food chemistry and auto chemistry. It's really a lot used titrations, and this is really the basics of doing calculations with molarity. I hope you enjoyed it. I hope you understand it. It's a really easy topic. I hope it is, and I used a really easy example. Next time I hope to do a more difficult example, maybe a protein calculation or a vitamin C calculation. I will see. And if you have more things you want to know about food or about science, about practicals, just comment and maybe we're gonna make a video out of it, or maybe not, because it's a lot of work. I made a video like this because it's basically really easy editing and I didn't have much time, so this is it, and I hope you enjoyed the video, and bye.